All right, just to look at what is a differential equation, right? If you remember the basics, right? The differential equation in general uh, can be represented in the following format. Okay, so this could be something like I write, say, an, it's a constant, into d to the n y by dx to the n, right, plus a n minus 1 into, this is d n minus 1 y dx to the n minus 1, plus you can have many terms over here, and maybe something like you get a1. See, the numbers are reducing, n minus 1, n minus 2, and so on. When you keep subtracting many terms, you end up with a1. Okay, n minus 1, n minus 2, n minus, like that you reach a1, right? I note one thing: if this is n, the d by dx is also raised to the power n. It's nth differentiation, nth differential we call. Okay, so this is a1 into, this is d to the power 1 y by dx power 1, and the last term power should be 0. I can write simply a naught into the power 0, so anything to the power 0 is 1, so I don't have to write a d by dx over here. This is equal to a function which is f of x. Normally, if anything is given in this particular format, right, then this is what is called as a differential equation. Okay, right, this is a differential equation of nth order. You can see that the highest power is n. Okay, so this is called as nth order differential equation. Okay, first thing to remember, right, normally we have a function called y is equal to a function. Y is a something like, okay, I write a different function here because it's not f of x, it's some other function, say g of x. You had a function like y is equal to g of x. You differentiated this so many times to get this particular equation. Okay, that's what is referred as differential equation, and you use the differentiation n times to get this equation, right? So you call this as a nth order differential equation. Okay, now there is another specific name for this equation because of the characteristic way of writing this. So let's refer this. You have an, which is a constant, right? It's a differential equation with constant coefficient. You can see that this is an, it's a constant. An minus 1 can be 5, can be 8, can be 3, right? Any number can be minus 5.8. So these a1, a2, a3, an, right, all are constants. So I can write ai, any value, is a constant. Okay, so now you see, since the coefficients of your differential terms, right, the d by dx, each of the d by dx is actually multiplied by a constant. That's why you call this as a nth order constant coefficient differential equation. Okay, so this is nth order differential equation, is also called as, right, the constant coefficient. Okay, so that's why the name is linear. I'll come to the term later. LCCDE. Okay, so CC is constant coefficient, DE for differential equation. Now I'll come to what is L. L stands for linear, right? The equation is referred to as the linear equation. It's because, you see, what's the equation of a straight line? If you remember, y is equal to m into x. Okay, this is a straight line. Now x is my variable, m is a constant. So this is one dimension. If you recall the multiple dimension equation, you can write this as m1 x1 plus m2 x2 plus m3 x3 and so on. Okay, so this is 1D equation. So I can extend this further to get into what is called as a n-dimensional equation. Now refer this with my LCCD I have written. You can see that constant variable, constant variable, constant variable. I mark the same thing now. You see, this is constant, this is a variable, constant variable, and so on, constant variable, right? If you write in this fashion, right, any equation is going to be called as a linear equation. Okay, so now I understand that this an d to the power n y by dx to the n, it's a m into x format. So because of this kind of representation, the equations are also called as linear constant coefficient differential equation. Okay, now let's come to, so somehow we formed the differential equation. Now we want to go back. Okay, so now our intention is to go back in the sense, right, this is given. Let's assume this is given for us. I want to find what y is equal to function of x, right, caused this equation, right? It's actually from the answer I'm going back. So previous step was, previously what you were studying was this. You had this, you were differentiating n times to come to this equation. That's what is called as forming a differential equation. Now we are calling it as a solving of the differential equation, right? So I'll just write that part now. So that is solving a differential equation in the sense, okay, I can write in this way: to obtain the function y from the given differential equation. So the first type of problems what we are going to solve will be, right, a straightforward question that is based on solving of the differential equation, which is LCCDE only, right? So the next level will be Cauchy's equations, Legendre's equations, and so on. They're not simple, they're difficult. So right, for just to understand the simple problems first, let's start with the a basic question. Okay, like you see, we are going to give a LCCDE now. So this is y triple dash minus 3 times y double dash plus 3 times y dash minus y is equal to 0. Solve this, right? Solve this means what? I'll write the differential version now. So this is triple differentiation. So I can write d cube y by dx cube minus 3 times d square y by dx square plus 3 times dy by dx minus this is y. Okay, minus y equals to 0. So you can see that this looks like 1 times this. So you can see that this is a3, right, into the d cube y by dx cube minus or I can write plus this is a2 times d square y by dx square plus some other constant a1 into dy by dx minus, right, you can have something like this format. So whatever format I wrote earlier, this particular equation is exactly in the format. Okay, so that's why I told we are solving the simplest problem now, which is called as LCCD, linear constant coefficient differential equation. Okay, now in order to solve this completely, right, because why I said completely, I'll come to that point later. Now, normally they will give some extra data. The extra data for this problem is y of 0 is equal to 2 and the y dash of 0 is also equal to 2, and let's say y double dash of 0 is equal to 10. So we have to use these values given to obtain the complete solution of this equation. All right, so before proceeding with the problem, let me come to the normal steps we follow in order to solve this. Okay, the steps will be, we will solve this any given differential equation in 2 steps. Okay, right, so the 2 steps will be as follows. Normally we have the differential equation that is on the left hand side. Differential equation is equal to f of x. Normally this will be in the following format. Okay, differential equation will be on the left side. Right side you have some function of x, but if I compare that with the given problem, I can see that there is a differential equation. This is the dE. Okay, this dE is here, but on the right hand side, I don't have anything. It is equal to 0. Again, that is actually the simplest case for this given problem. Normally, problems will not be this much easier. Okay, normally you have something on the right side. Okay, that is some f of x will be present in any of the given uh, equation. Normally you have that. Okay, but now I told we solve the problem in 2 steps. Okay, the first step is assuming that this f of x is there. What you do, you replace f of x by 0 and solve. That's what we are going to do now, because this problem does not have a right hand side. You already have done that, it's already given as 0. But if it is not 0, there is some f of x. For example, this could have been the sine of x, right? You see, the sine of x means it is a f of x. So the same differential equation could have been equated to right side sine of x, sine 2x, e to the power 4x, anything. Okay, that's possible. But in this case, it's not that case, right? So if at all there is a sine x, cos x, or any function on the right side, my first step is to remove that and make it equal to 0. Okay, but in this problem, it's not there. It's already given 0. Okay, so when you make the RHS equal to 0 and solve, right, you will get one equation. Okay, you will get one equation, in the sense you get one solution, because right, something equal to 0. Normally, if you recall the algebra, we had something like y square plus 3y plus 4 equal to 0, right? RHS is 0. When you solve this, you get some answer, right? You get an equation, y equal to, say, maybe 1, and y equal to maybe minus 3, something like this. We get an answer, correct? So that's a solution. Okay, this particular solution is called as a complementary solution, right? When you equate the RHS to 0 and solve, you get a complementary solution. Okay, so I'll write this part because this is important. Okay, I'll write it in this way. So any given differential equation is given, right? We solve it in 2 steps. So step 1 is to find the complementary solution yc. In the sense, it's an answer. Yc is a step 1. How do you find yc? Right, you make the RHS equal to 0 and solve. Anyway, we'll solve more type of problems later, right? For the time being, just remember this point. Then we have another step, that is step number 2 is to find the particular solution. This is yc. I'm going to call it as a complementary solution. Yp is called as the particular solution. All right, now the particular solution comes by substituting whatever was the f of x in the given equation. You will put it back and you will solve. So 2 steps. These are the 2 basic steps. Once you get both of them, then your solution, because our intention was, you can see that when we discussed about solving a differential equation, it is to find a y. Now, what is the y for the given question? It's like y is equal to the complementary plus the particular. Yc and yp you find separately, right? When you find both of them, substitute back, add them together to get the total y. So this y is what we call as the solution of the given differential equation. Okay, but if RHS is not given, no need to worry, only YC is there. YC itself is this, because YP will be 0 in that case. Okay, right? This is the way how you solve. Okay, now what I do, I copy this so that we can solve this problem directly. I'll just go to the next page. All right. Okay, Control C. All right, so fine. So this is the given question. Now we'll solve this. So how to find the YC? Because this problem is just a YC question, right? So to find YC, we follow the following steps. Okay, so to find the YC. In this case, YC itself is the answer because RHS is already 0. What you do, right? You replace the first step is this. I'll call this is equation number 1. So just remember the same steps. Whatever step I'm going to follow, right? You are also going to follow the same steps for any given problem. Okay, so this is the first step. Replace the d by dx. Okay, replace the d by dx by capital D. So which means in the given equation, wherever I see d by dx, you can see that there is a d by dx over here. There is another d by dx over here, right? Neglect the power, right? Power I'm going to consider later. So there is another d by dx over here. Okay, replace each of the d by dx by capital D. So see the first substitution I'm going to make. So this is capital D. So there is a cube over there. So d cube remains as it is. D cube into y minus 3 times. This is d square y, right? Plus 3 times capital D into y. I'm not touching y. I'm just replacing d by dx. Wherever I see a d by dx, I write it as capital D. If there is a power, write the power as it is. Okay, so I did that. Minus, see, there is a y. We are not going to touch that y because there is no d by dx. Y will remain as it is. RHS also will remain as it is. Okay, right. Now what I can see here is I see a y common in the whole equation. I can take the y out. When you take the y out, what remains? D cube minus 3d squared plus 3d minus 1. Okay, take y outside. Y is common here, 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 and here. So when y goes out from the last term, there is a 1 remaining, minus 1. Okay, this RHS we are not going to change. Keep RHS as it is, which is equal to 0. All right, fine. Now let's go further. Right, in the next step, what I'm going to do here, I'm going to use a very basic mathematics. All right, here. So that is, see, if at all you are solving a algebraic equation, maybe a quadratic equation like x squared plus 4x plus 3 is equal to 0, something like that. Maybe you are solving, you get two terms, right? Maybe x minus 1 and x minus 3 possible. Okay, uh, in this case, if at all you write this is equal to 0, what is the solution that you are writing? You are writing like this is x minus 1 equal to 0 or x minus 3 is equal to 0. You do like this because when a product is equal to 0, a into b is equal to 0 means either a equal to 0 or b equal to 0. Correct? So this is the simplest solution which we use in mathematics, right? In most of the cases. Which one? Simple quadratic equation. Okay, I'll solve that. All right, so it's this way, right? If at all you take any quadratic equation like x squared plus 4x plus 3 is equal to 0, right? The solution, normally what you write here is like you try to factorize it in such a way that, right, maybe you can write, you have to split the 4x in such a way that x plus, I can write 3x plus x plus 3 equal to 0. I'll try to write in this way. Now what I can see here is uh, the x plus 3, I can take okay, sorry, this is x square. I can take x out here. So the first term, if you take x out, this is x plus 3, next plus 1 into x plus 3 equal to 0. Now you see that x plus 3 common. I'll take this as in this way. X plus 3 is 1 and second one is x plus 1 equal to 0. So you can see that this x, this 1 and this x is here. So these are the two factors of the given equation. I'll tell you the other method after this. Now this is manual calculation, okay, not using any of the equations. Okay, if this is the case, your answer will be either x plus 3 equal to 0. I am trying to equate this to 0, or my other option is to equate this, that is x plus 1 is equal to 0. So this means what? I can take the 3 to the other side, x equal to minus 3 is one solution. Similarly, put x equal to, right, take 1 to the other side, x equal to minus 1 is your other solution. Okay, so this is how you solve any given equation, any given quadratic equation, right, by manual approach. Right, you have to, this comes from practice. Okay, there is no fixed rule in this method. How to split this into this and this? You see, in this case I try to split 4x as 3x plus x. You could have done 2x plus 2x, right? But in that case you don't get a solution. It has to be 3x plus x only, then only you will get a solution. Okay, that's why I told it comes from practice. Okay, that's a method number one, right? Let's go to the method number two. I'll continue the differential equation problem later. Let's discuss the solution first. Okay, now any given quadratic equation is of the following type. You will have ax squared plus bx plus c equal to 0. For example, look at the given question. This is x squared plus 4x plus 3 equal to 0. So I can see that in this case a is equal to 1, b is equal to 4, c is equal to 3. If this is the case, then you actually have a standard formula that you can substitute. Okay, so the roots are, there are two roots. Okay, the roots are x1 comma x2. x1 comma x2 can be calculated by using this method. This is very famous method. You may be aware of it. So the solution is minus b plus or minus root of b square minus 4ac whole divided by 2a, right? You need to have the ABC ready with you. You can simply solve this to get the solution. Let's check whether we get the same answer. Like manual method, I got minus 3 minus 1. Now I should get the same answer using even this method. So substitute. Okay, this is minus b, so minus b is minus 4 plus or minus, in the sense I need two answers, right? X1 and x2. For first one you use a plus, second one you use a minus. That's why it's a plus or minus. Okay, so minus b plus or minus root of b square, 4 square, 16 minus 4 into a into c, so 4 into 3, 12 whole divided by 2 times a is equal to 1. Okay, so this is minus 4 plus or minus, so this is root, so you can see that this is 16 minus 12 is 4, root 4 I can directly write, root 4 is equal to 2, right? Plus or minus 2 divided by, this is how much? 2. Okay, so this means I can have the following two answers, that is equal to minus 4 plus 2 by 2 is one answer. Otherwise this is minus 4 minus 2 divided by 2. So minus 4 plus 2 is minus 2, minus 2 divided by 2 is minus 1. Or the other answer, minus 4 minus 2 is minus 6, minus 6 by 2 is minus 3. See, you get the same answer, minus 1 or minus 3. Okay, so the same minus 1 minus 3 you can get using the standard method, that is actually using the equation. So you need to remember this equation if you want to solve using the equation method. Okay, standard equation. Sorry. Root 3, you calculate using calculator. Root 3 will come as 1.7 something, right? So you will substitute that. Doesn't matter, anything that comes you have to substitute. In that case the answer should be minus 4 plus or minus root 3 whole divided by 2. This will be your equation. Okay, so what you do, your solution should be minus 4 plus root 3 by 2 or minus 4 minus root 3 by 2. Root 3 you can substitute as 1.71 in calculator. right? 1.71. So minus 4 minus plus 1.71 by 2 is one answer. Minus 4 minus 1.71 by 2 is your second answer. All right. So doesn't matter, right? Any value that comes over there under the root, you will be able to calculate anything. Okay, these are the two methods which we use. But since the calculators are allowed now, right, in engineering course, you can simply solve in the equation. There is what is called as an equation mode in your calculator. Okay, scientific calculator. uh, since I'm not aware of what exact calculator you are using, I may not be able to tell the straightforward way. You can explore that. There is what is called as equation mode. Okay, go to the equation mode in your calculator. It allows you to enter the equation as it is, like x square plus 4x plus 3 equal to 0. You can enter this. Okay, and then you have an option to say solve, and when you click solve, it's directly going to give you the answer -1 or -3. But anyway, that's the easiest way. But we still prefer knowing the basics by knowing how to solve. Even if there is no calculator, we should be able to solve. That's our motto. So always suggested that you should know this one equation, so that in some cases when we don't want to use a calculator, still we should be able to get the answer. Okay, hope this point is clear, right? Now I'll come back. So we had this equation with us. I'll continue from here. I'll just copy and let me paste. Okay, now this was the equation we had. So what my intention is that I have a product. Take this as A and take Y as B. AB is equal to 0. What we did earlier, we actually A into B is equal to 0 means either A is equal to 0 or B is equal to 0. One of them has to be equal to 0, so that the term becomes equal to 0. That's from basics. We know that either of them have to be equal to 0 or both of them have to be equal to 0. But now the point here is that I will equate only this to 0 and I will not equate this to 0. I'm very sure that B is not equal to 0. Only A has to be 0. A means the differential equation, the d power cube, d cube minus 3d square plus 3d minus 1. Only that equation what we have, only that has to be equal to 0. Y cannot be equal to 0. It's because, see, Y is my solution, right? Y is what I'm trying to find out. If you say y equal to 0, it means your answer becomes 0 ultimately, right? That's not the case. I'm trying to find out what is my y, right? My intention is to find out y, right? So y cannot be equal to 0. Y not equal to 0, right? This is because of that reason, because this is my solution. I cannot say that y is equal to 0. In every problem, this will be equal to 0 in that case. So because of that, for that reason, y cannot be equal to 0. So when y is not equal to 0, we will write the other term equal to 0. D cube minus 3d square plus 3d minus 1 has to be equal to 0. Okay, now what happens here? The thing is that the d is a operator. D is what? D is actually equal to d by dx. It's an operator. I cannot use an operator in, right, in any equation. I cannot solve an equation where the variable is an operator. This is something like you are writing like plus cube plus 3 times plus square. There is no meaning for that, right? Because plus is nothing but it's equivalent to a d by dx. It's an operator, right? So in the first step, we replace the d by dx by capital D, right? If I try to solve this now, this has no meaning because you are trying to solve for the value of an operator. Operator has no value, variables will have a value. So for that reason, what you do, right, I cannot solve this equation as it is mathematically. Simply I can solve and I can get a value of d, but since d was equated to a operator, there is no, it's mathematically illegal, incorrect, right? So what you do, you replace d by m and call it as an auxiliary equation. Whenever you do this in mathematics, it's called as auxiliary equation. AUXILLERY, auxiliary equation. It's in short AE, right? AE is given by, replace this d by any variable, in the sense m cube minus 3m square plus 3m minus 1 equal to 0. Now this m is a variable. Its m is not an operator. Since m is a variable, I can solve this. Okay. Again, right? Solving this kind of equations has, right, many options. Let's use the one option that's the simplest one. See, if at all this was a square, I already have given you the equation for that, right? Standard equation, minus b square plus or minus root of b square minus 4. Sorry, the equation was minus b plus or minus root of b square minus 4ac whole divided by 2a. That equation was discussed earlier, and that is valid for power equal to 2. Now you see, in this case the power is equal to 3. There is no standard equation for this. Okay, there is what is called as a synthetic division method, right? You just have to create a table for that. Okay, that's the simplest way. But before going that, the condition here is that you need to find one of the solution, because how many values of m we are expecting? M values will be 3. Why 3? Because there is a power 3. So previously, if you see the previous equation which we solved, the highest power was 2. I'll go back. So see, the highest power was 2. That's why you got two answers here, x1 and x2. Now the power is 3. So since this power is equal to highest power is 3, I'm expecting m1, m2, m3. Okay, fine. Now how to solve that, right? This can also be solved very easily, right? The condition here is that you need to identify one of the solution. Out of the 3, one you have to find out somehow. So what is the best method to find that? You keep substituting random values of m. Okay, so let's start with m equal to 0. M equal to 0 means what happens? This is 0 minus 3 into 0 plus 3 into 0 minus 1, means this is not equal to 0. So this is not a solution. Okay, when you put m value, you can put different values of m, and you need to find out a m value such that it gives you equal, it's when you substitute that value, it gives you 0. Okay, fine. Now let's put a different value. This is not the answer. M equal to 0 is not one of the answer. Let's go with the other one. Put m equal to 1. What happens? This is 1 cube minus 3 into 1 plus 3 into 1 minus 1. Correct? So you can see that this is equal to 0, which means m equal to 1 is one of the answers. So I got m1. m1 is equal to 1. Similarly, I can definitely keep substituting all the possible values and I might get the solution. Okay, but that is not so easy always. What if my answer lies between 1 and 2? 1.35 is my answer, possible. I will never be able to find that. So I cannot repeat this. Only one of them I can find out somehow. Okay, so what we do now is we'll go ahead in this fashion. So find one of the roots somehow, right, by making a substitution. Once you do that, right, I have to write the coefficients of the given equation, that is this. Okay, write the coefficients. M cube coefficient is 1. Next, m square coefficient is minus 3. Write one after the other. Okay, 1 minus 3, then I have a plus 3, then I have minus 1. Okay, then always below your first number, that is 1 in this case, you write a 0. You start with 0. Okay, right, then you will write like this. Add the first, okay, whatever is your m1, right, that m1 you write on this side. This is m1 equal to 1. Okay, standard procedure, always you write this way. right? This makes our problem, we can solve this problem very easily. You will come to know now. What I do, I add the column wise. Okay, 1 plus 0 is a 1. Then whatever you get here, you multiply this with the root you get. Already you got one root, right? Multiply that with this number 1 into 1 and write that answer here. So this into this, the product will be written in the next position. Okay, and what you do, you add column wise. Every column you get, you add. Minus 3 plus 1 is minus 2. Okay, see, this is minus 3 plus 1. Minus 3 plus 1 is minus 2. So what you do, you repeat the same thing. Minus 2 into 1, you get a product. Write that in the next column. So minus 2 into 1 is a minus 2. So whenever you get new thing, new column, you add. Right? How do you add? So 3 minus 2 is plus 1. So this one, once again multiply with 1. Okay? What happens? 1 into 1 is a 1. So minus 1 plus 1 is a 0. Okay? Alright. So now let's go ahead. Now what I do here, I had a m cube term, right? M cube term referring to this equation. See this equation. M cube, m square, m and this. Out of m cube, I have got one solution. Now how many solutions I need to find? I need to find two more solutions. Okay, I need to find two more values of m. In the sense, I am supposed to get a second order equation. So second order equation you obtain by using this m square, m and m power 0, that is equal to 1. Okay, I can write 1 here. In the sense, it is m power 0. See, decreasing order, m square, m power 1, m power 0. So club them together, multiply and get equate it to 0. That is 1 into m square is a m square. Minus 2 into m is a minus 2m. Plus 1 into 1 is a 1 equal to 0. See, now you got a m square. Equation in terms of m square. So whenever I get equation in terms of m square, if you solve, what do you get? You get two roots. So what are the two roots you are going to get? You can get m2 equal to and m3 equal to, because m1 is already formed, right? I know what is m1. m1 is there. See, m2 and m3 I can find by solving. This is a m square equation. So for any squared equation, I know many methods, right? Multiple methods do exist. Either you can use a calculator, you can use the equation, or you can simply decompose this into two factors and you can solve. I prefer that method because that's the easiest one. I don't have to substitute in an equation. So how do you solve manually? Let's do this. This is m square minus 2m plus 1 equal to 0. This is my equation. What I do, I split this. That is m square. Okay, let's split this as minus m minus m. See, minus 2m is nothing but minus m plus minus m. Right. Plus 1 equal to 0. I can see that m is common from m square and m. So this is m minus 1. Then I take a minus 1 outside. I'm left with m minus 1 equal to 0. Again, as I told, this comes from only practice. So I can see that m minus 1 is common here in both the terms. I can take it out. So that means m minus 1. When the m minus 1 goes out, what is left over is also m minus 1 in this case. See, m minus 1. So what I do, I write another term that's also m minus 1. m minus 1 into m minus 1 equal to 0. This means m minus 1 equal to 0 means this is m equal to 1. M minus 1 equal to 0. That also implies m equal to 1. This will be m2. This will be m3. So all the three roots are 1, 1, 1 in this particular case. So you write down m is equal to 1, 1, 1. So this given equation had three roots and all the three roots are equal. Okay. All right. Now, so whenever you find that the roots are equal, right, normal, I'll come back to the normal technique first, then I'll go to the equal roots. When the roots, you have a auxiliary equation AE, you solve the AE and you get one equation like this, right? You get the roots. Any AE you solve, you get roots. By looking at the roots, you can write the YC directly. Okay, there is no need to do any other calculation. By looking at what type of roots you got here, you can write the what you call, you can write the YC directly. Okay, right. So now since the roots are equal, right, what you can do here is that the YC can be written directly in the following format. The format is like, you start with, you look at the number, you look at how many roots you have. In this case I have 3 roots. Okay, 3 roots you have, and the equation you are going to write will be of the following format. You start with a constant plus c1 x plus c2 x squared plus c3 x cube and so on. But you count the terms. Terms should be equal to the number of roots here. See, I have 3 roots, so I should stop here. I should not go beyond this in this case. But in general, you have to keep expanding this until you finish the number of terms. Terms are equal to 1, 2, 3. If you have 3 roots here, you have to calculate, you have to write the terms until you get the 3 terms. You keep writing. So if at all this was, let's assume that this is 1, 1, 1, comma 1. One more 1 was there. Then you are supposed to write C3 x power 3. 4 terms in total. Okay, that's what I meant. Now since we have only 3 terms, I can see that there are only 3 terms in the sorry, there are only 3 roots in when I solve the auxiliary equation. So because of that, the YC term I'm going to write till here only. I'm not going to extend this further. Are you okay? So this is the term into into the standard term is e to the power, this is m into x. M in the sense the root. I can see that all the roots are 1, 1, 1. So I am writing this as e to the power 1 into x. Okay, so this is e to the power 1 into x. This is my answer. Okay, but this is not a complete answer because there are some unknowns here. C1, C2, C3, sorry, C0, C1, C2 are unknown. I don't know. All right, so how to find that, right? In order to find the values of these unknowns, I am supposed to use the values given extra values given in the question. For example, in this particular problem, they have given some values. That is, y of 0 is equal to 2. They have mentioned this. This means that when x equal to 0, the y is equal to 2. So y in the sense the left hand side. Put x equal to 0 in the above equation. Y should be equal to 2. So left hand side, this implies yc is actually y only now because I don't have any other term on the right hand side of the given equation, right? So because of that, I can simply write 2 is equal to, substitute. So C0 is not known, I'll keep it as it is. C1 into x, what is x? X equal to 0, so this term become equal to 0. Okay, so this is 0 plus C2 x square, x is 0, x square is 0, so C2 into x square is also 0 into e to the power 0. Okay, so e to the 0 is 1. Okay, this means this term is 1, so 2 is equal to C0 into 1. This means what? I found the value of C0 equal to 2. I got one of them. I can substitute this. Okay, I got the value of C0. Okay, now what we'll do, they also have given another value, you can see that in the question they also have mentioned another term. The term is like y dash of 0 is equal to 2. This means what? This means if x equal to 0, then the differentiation of y, that is y dash, becomes equal to 2. Okay, so in order to substitute this, I need to differentiate this because it says that y dash is equal to 2. Y dash, in the sense, it's a differentiation. Okay, let's find the differentiation first, then we'll substitute. Okay, so let's calculate the differentiation. If you see the differentiation, it is actually, it has two terms, right? The two terms are like this. Sorry, I'll come back. So the two terms what we have are this. See, this is the term number 1. This is u, this is v. If you have u and v as a product, there is a product rule for differentiation. So differentiation has to be done using product rule. That is u into dv plus v into du. Take anything as u and v, doesn't matter, you still get the same answer. So I'll write the differentiation now. I'm trying to differentiate the given yc. So this is yc dash is equal to u dv is nothing but, right, you keep the u as it is, differentiate v. So u is nothing but my first term, so c0 plus c1x plus c2x square into differentiation of the second term. E to the x differentiation is e to the x itself, so I don't have to do anything. Plus, now what you do, you keep the second term as it is, that is e to the x, into differentiate the first term. First term in the sense c0 differentiation is 0, c1x has differentiation c1, and c2x square has a differentiation 2 times c2 into x. Alright, now you substitute the given thing. When x equal to 0, y dash is equal to 2. So y dash is 2 on the left hand side. C0 value I know. If you remember, the C0 value came as 2 itself. So 2, all others value will go away because the x is 0 into e to the 0 plus one more e to the 0. E to the 0 is 1. So plus 0. I just have a c1 plus 0. Okay, now you can simply substitute. The 2 is equal to 2 plus e to the 0 is 1, so this is equal to c1. Okay, so 2 cancels, 0 on the other side. This implies c1 becomes equal to 0. Okay, I got this. So I got a value of c0, I got a value of c1. Now I need to calculate the value of c2. Okay, how to find the value of c2, right? Use the third value that is given in the problem. In the problem statement, they also mention that, right, y double dash of 0 is equal to 10. So this means if you substitute x equal to 0, then the y double dash is equal to 10. But I don't have a y double dash. I need to find that. So how do you find y double dash? I have a y dash. Differentiate this once again. Okay, when you do that, you get the solution. So let's do that. That is yc double dash. Yc double dash is equal to, I have to do differentiation maybe 4 times now, because this is u, this is v, this is another u, this is another v. So uv 2 times. So okay, so it's the same rule. I have to do twice, that's all. So let's do this now. So first let me keep the first term as it is. First term is c0 plus c1x plus c2x square into e to the x, plus keep the second term as it is, e to the x, into this differentiation. Differentiation of c0 is 0, c1 plus 2 times c2 x square. Not x square, my mistake, c2 into x. Okay, this is nothing but this being differentiated like this plus this. But there is another term, right? Now I am going to solve that term. Product rule, because I can see a product here. You see, this is one term, this is the second term, u and v. So what's the rule says? Keep u as it is, take a differentiation dv. E to the x differentiation is e to the x, plus keep v as it is, v in the sense e to the x. Okay, into differentiation of this comes over here as du. Yeah, that's actually more complex. That becomes more complex than this method. Okay, you can definitely do that. All right. What happens, I'll tell you. The e to the x into x square is another uv, right? So you see that x square e to the x will come there. This is u, this is v. Once again, you need to apply the same rule. Okay, if you multiply. Okay, same rule will come once again. Inside the brackets after multiplication, you get once again uv only. Just to avoid that, this is the easiest way. Okay, all right. Again, it's optional. You can definitely do that. According to me, it will take more time, and there will be more steps than this method. Okay, all right. So let's continue. There is another uv. I can see in the yc dash. I can see another uv. So we are supposed to differentiate that now. So this is going to be my u and v. Okay, so this is u, this is v. So this is plus. Keep the u as it is. That is c1 plus 2c2x into v as it is, e to the x, plus keep the second term as it is, e to the x, into differentiation of the first term. C1 differentiation is 0. This is 2c2. 2c2x differentiation is 2c2. All right. Okay. Now they say that when x equal to 0, the left hand side becomes equal to 10. So this is 10 is equal to, I can substitute the value of c0 and c1 because you know the values. So c0 is equal to 2 plus 0 plus 0, e to the power 0 is equal to 1 plus 1 into c1 is equal to 0. Already c1's value is 0, so I am substituting 0 and plus 0. This is gone. Next term plus, what's the value of c1? 0 plus 0 into e to the power 0, which is equal to 1, plus e to the 0 is 1, not plus, my mistake, into 2c2. c2 is unknown. I am finding the c2 itself now. Okay, fine. So this means, let's calculate the value now. So 10 is equal to, this is 2 plus the second term is 0, third term is 0, fourth term is 2c2. Okay, now 2 I am going to take to the other side. So 2c2 is equal to 10 minus 2 is equal to 8. This means what? How much is c2? c2 is equal to 4. So I got c1, c0, c1 and c2. Therefore, now you have the exact answer required for this problem. That means, so the solution y is equal to actually yc itself. Okay, I can see that yc was given as c0 plus c1x plus c2x square into e to the power x. Okay, now you substitute, you know the values. C0 is 2, c1 is 0, so I don't write. C2 is equal to 4 x square into e to the power x. Okay, you can see that this is a proper f of x. F of x in the sense some g of x. I told initially, if you remember, I told y is equal to g of x should be my answer. Y is a function of x I am expecting. You can see the y which we got now is only a function of x. It can be sin x, cos x, e to the x, right? Anything, e to some 2x plus 3 into something, anything. You see over there completely, right? The function is made up of x. That's what is the required answer. I'm supposed to get only this. I should not have a y over there. I should not have a dy by dx over there. It should not be there. Proper function of x is expected, and now we got that. Okay, so this is the solution of this particular given differential equation. Okay, all right. So